Hello there. In this lesson I'm going to introduce you to some terms concerning functions. I'm going to explain the terms injective, surjective and bijective. And first of all we're going to look at when a map is a function and when it isn't. So here you see two graphs. On the left we have the graph which is a function, and on the right we have a graph of a map which is not a function. So why is the one on the left a function? Okay, a map is a function if each input is mapped to one output. Now remember, your inputs come from this x-axis. So to find the output associated with an input, we just draw a vertical line either up or down until we meet the graph. And there's the output associated with that input. This input, for example, is mapped to this output. So for each of these inputs there's a single output, and in that way we can write our x as our input and our y as our output as an ordered pair. You can do this for all functions. Now on the right we have a map, but let's say this input here, if we draw a vertical line we meet the function twice. So we cannot say what exactly is the output. Is it this one up here? Or is it this one down here? So if it is mapped to more than one output, it is not a function. So the one on the left here is a function. But the one on the right is not a function. Now it's very important that you understand this definition. Let's look at it one more way. If we look at it in terms of the sets, the domain is the inputs and the codomain is all of the possible outputs. You can see that on the left here each of the inputs is mapped to one output, so we could write the pair of coordinates. It doesn't matter that two of the inputs are mapped to the same output because they can both have the same y coordinate. For example, this could be A and this could be B and this could be C, and we can just write AC. We can write BC as well. That's perfectly fine. But here we see that, for example, if this one was A and this B and C, then A is mapped onto two different outputs, and this is not possible. Not possible for a function. Okay, the next definition is injective. Now a function is injective if no two inputs have the same output. Well, we saw above that an example where A and B have the same output. So this function above is not injective. But here we have an example on the left of a function that is injective. All of the inputs are mapped to a single output, and a unique output at that. So they each have their own unique output. And to test we just check all of the outputs, and there are three outputs in this codomain. So those correspond to the range. Each of those outputs has got a unique input. Whereas on the right we have an output here and it has two different inputs. So on the left we have what is an injective function. But on the right it's not injective. Why? Because we can find an output which has more than one input. Another word for injective is one-to-one. So here on the left you can see that there's a one-to-one correspondence between the inputs and outputs, but on the right there's not a one-to-one correspondence. In fact, two go into one, so it's not injective. Here's an example of a graph which is injective. All of the outputs have just got one input. So if you were to map from the outputs, you'd get a unique input, and if you took a different output, you would get a different input. Whereas here we have a single output but there's two different inputs. So both A and B are both mapped to the same point, which as you can see from the sets above, we could have, for example, here, let's do the same color. We could have A and B both mapped to this point here. And what do we call it? Well, you know, it's a function, it's fine, but it's not injective. Okay, it's not one-to-one. Let's look at a function which is surjective. Now, a function is surjective if every element in the codomain B, okay, has some element from the domain A mapped onto it. In other words, for all B, little b in capital B, so all the little b's, set the elements in the codomain, for all of those, there exists, that's what this term means here, there exists an element in A such that f of A is equal to B. Okay. So, for example, this might be little a and this might be little b. So f of A is B. On the left here, all of the elements of B have something mapped onto it. So this one is surjective. Whereas on the right, we have these three elements down here with nothing mapped onto them. So this is not surjective. Again, if we look at the definition of surjective, it's also called onto, and there are three elements here in the codomain which have nothing mapped onto them. So for it to be onto, everything in the codomain must have something mapped onto it. So this one is not surjective. But this one is. Finally, a function is bijective if it is both injective and surjective. Okay, so let's try and draw an example of this. First of all, we need a one-to-one mapping. So let's put some points in here. And that can be mapped to that, and this to that, this to this, and this to this. Now we don't want to put any more points in our codomain which have nothing mapped to them, because then it would not be onto. And similarly, we don't want two different points mapped onto the same output, because then it would not be one-to-one. So this one here is both onto, so it's injective. Tick. It is surjective. Tick. So it is bijective. Therefore, bijective. If we scroll right to the top of our lesson where we had an injective function, you will notice that I stuck in an extra element in our codomain. So while this is injective, it's not surjective, because all of the points in the codomain don't have something mapped onto them. And when we did our surjective example, I made sure that 2 points were mapped onto a single point in the codomain, so this is not injective. So the first example we get of a bijection is down here. Let's put our arrows in. So we have our domain here, our codomain. If it's a bijection, the codomain will actually be equal to the range. The range is the set of actual outputs, and the set of actual outputs should be the same as the possible outputs in a bijection. Okay, thanks for watching this video. I hope that it helped. See you in the next one.